In this question, we have a wedge. The block of mass m is at its highest point at initially, and there's a spring over here. Now we need to find out what will be the maximum compression of the spring once the block slides down this and pushes the spring. We need to find out the maximum compression of the spring. So initially, first of all, you must understand that the maximum compression of the spring will occur at the point when the speed of this block of mass m becomes 0. This block comes down till here, pushes the spring, comes to rest, and that is the point when the spring is at its maximum compression. So now, during this whole motion, work done by external force on this block is 0. The only external force acting on this object is the normal force, but the work done by, there is another external force, but that is counted as a conservative force. Apart from the conservative forces, there is only one external force, that is the normal force. The work done by the normal force is 0 because the normal force is always perpendicular to the displacement, due to which the work done by normal force is 0. There are also no other internal non-conservative forces. There are no internal non-conservative forces, due to which the work done by internal non-conservative forces is also 0. Work done by internal non-conservative forces equal to 0. So work done by external forces is 0 and work done by internal non-conservative forces is 0. Under these two conditions, you can always apply the mechanical energy conservation. Whenever you apply mechanical energy conservation, you must keep in mind these two conditions, that work done by external should be 0 and work done by internal non-conservative forces should be 0. People generally forget these two conditions and come up making a mistake. So please check these two conditions before applying mechanical energy conservation. So by applying mechanical energy conservation, on the block from its initial position A to final position B when the spring is at its maximum compression. So potential energy initial plus kinetic energy initial is equal to potential energy final plus kinetic energy final. For determining the gravitational potential energy, we have to assume potential energy to be 0 at a particular level. Let us assume potential energy to be 0 at this level. You can assume potential energy to be 0 at any level you choose and you will get the right answer, but taking into account simplicity, we take potential energy equal to 0 at this ground level. Now we write the initial potential energy as mgh 400 by 1000 into G into 4.9. This is the initial potential energy. Initial kinetic energy of the block was 0. The final potential energy, the final gravitational potential energy of the block is 0, but finally there is some spring potential energy which you have to write over here, that is equal to half k x square plus final kinetic energy of the block is again 0. So here we go about solving this question. 4g by 10 into 4.9 is equal to k. The value of k is given to be 400 Newton per meter, is equal to 200 x square. So we solve this equation. x square is equal to 4g by 10 into 4.9. We solve this to get x square as 0.098 whole square. Therefore x comes out to be 0.098 meters, which is equal to 9.8 centimeters. So a final answer for the maximum compression in spring is 9.8 centimeters.